Good day and welcome to today's webinar on Fusion 360 from solids to parts and assemblies. My name is Arthur van Wijngaard and I'm an applications engineer with the Moderna OneSolve team. Looking at the agenda for today's webinar, we will first look at the difference between a body and a component. Then we will go and create a component. We will look at the types of joints. Then we will add joints to our assembly. And then lastly, we will have a Q&A section. Let's have a look what the difference is between a body and a component within Fusion 360. A body in Fusion 360 represents a single continuous solid geometry. It can be thought of as a single part or object in your design. When you create solid shapes, extrude sketches, or use any feature that generates geometry, Fusion 360 will often create separate bodies for each distinct solid object. Bodies can be combined using Boolean operations like union, subtract, or intersect to create complex shapes. A component in Fusion 360 is a higher level organizational unit that can contain one or more bodies. Components are typically used to represent individual parts or sub-assemblies within your design. They help you manage and structure your design. By using components, you can create an assembly where each component represents a unique part, and they can be moved, rotated, and assembled relative to one another. The key differences between body and components. Bodies are basic units of geometry representing individual solids, whereas components are higher level units of organizing parts and sub-assemblies in a design. A component can contain one or more bodies, but a body cannot contain other bodies or components. Bodies are used for creating geometry and performing modeling operations, while components are used for creating assemblies and managing the relationships between parts. Components allow you to easily manage multiple instances of the same part in an assembly, making it easier to design complex models and track changes across assemblies. In summary, bodies represent the solid geometry, while components are used to organize and assemble those bodies in a complete design. By using components, you can build and manage complex models more efficiently, making Fusion 360 a powerful tool for both part modeling and assembly design. Next, let's go into Fusion 360 and create our own component. In this design, we will look into creating a connecting rod to drive the blade assembly. The connecting rod will connect the large spur gear and the blade holder. Before designing our component in Fusion 360, first we will simplify the model and making it easier to access the models we need to reference, and temporarily moving the geometry we don't. To do that, we hold Ctrl and select the components in the browser. Right-click, and we select Isolate. Next, we are going to create a new component for the connecting rod. We'll go down to Create, New Component. We will call it Connecting Rod. Press OK. Now that we've created our new component, we will start by adding construction planes. I will create a mid-plane between the blade holder assembly. Now that we have created our construction plane, we can now start by adding sketches to it. I'll go to Create Sketch. Just change my visual style. Now we can start drawing up our 2D geometry. First, we will need to create a parametric relationship between the components. So for instance, if we change the size of the pins, we want our connecting rod holes also to change. The way we do that is go down to Create, Project, or you can use the P shortcut. Next, we will start by drawing a circle in space at 20 millimeters. And instead of moving it to the center, we can just use the concentric constraint. We'll create another circle, and instead of saying it's 20 millimeters, we can use the equal constraint to ensure that both circles are the same. Next, we want to create the center section of the connecting rod. The way we're going to do that is we will create a construction line in the middle between these two centers and then just offsetting it. Offset it by 5. And now that we've done all of our 2D geometry sketching, we can start by cleaning up the drawing. We'll change this center line into a construction line, and we'll trim off these edges. Then we will finish sketch, and then we will start extruding. Now that our sketch has been completed, we can start with extruding. First, we will start with the extrude command, extruding this circle first. The direction, we will make it at symmetric. The distance will be 6.5. And select OK. You notice that once the 3D geometry has been created, the sketch is no longer visible. To bring that back, you go down here to your connecting rod, down with the arrows. Where the sketches is, just click on the eye to bring it back. We will continue with the extrude command, doing the other circle. With this, we will go at 2 sides. The first distance will be 4, and then the second distance is going to be 3. Select OK. Next, we will extrude the center section of our rod. We'll say symmetric by 3. And select OK. With the basis of our component completed, let's add some fillets to the connecting rod. First, we will go to our fillet command. Then we will select the edges. We want to fillet. The size, we will make this 3.5. We'll select these edges as well. We will make those 3. Now we will select the top and the bottom fillets. And we will make that 1.5. And click OK. As you can see, our fillet has been added to our component. The final step into creating our component is to remove the material to connect the blade and the assembly. To do that, let's create a sketch, offset for clearance, and we'll extrude. symmetric. Select OK. As you can see, we have cut through our components. Now that we have completed integrating our component, our next step will be into looking into assemblies and joints. These are the types of joints that is available in Fusion 360. You have the rigid joint, the revolute joint, the slider joint, cylindrical, pin slot, planar, and the ball joint. So let's have a look further into these joints and how they work. First, we have the rigid joint. This joint fixes two components together, removing any movement between them, creating a fixed connection. An example of that would be a weld or a bolt. Next, we have the revolute joint. This joint allows rotational movement around a specific axis, like a hinge or a wheel rotation. An example would also be a lever arm. Next, we have the slider joint. It permits linear motion along a defined axis, similar to a drawer sliding in and out. Also, another example would be a piston. Then we have the cylindrical joint. This joint combines both rotational and linear motion, allowing movement along and around a specific axis. So this would also, an example of that would be a screw. And this is a combination of the slider and revolute joint. Next is the pin slot joint. It enables linear motion along the slot, as seen in a sliding bolt or a key in a keyhole. An example of that would also be a pen clip. Next is the planar joint. This joint restricts movement to a specified plane, like a door opening and closing along a fixed surface. Also, another example of that would be a chess piece. Then we have the ball joint. It allows for rotational movement in any direction, emulating a ball in a socket joint. Another example of that would also be a tripod base. Now that we have modeled up our component and looked into the different types of joints Fusion 360 provides, let's start by putting some joints into action in our assembly. If you have used other CAD programs before, you may be used to constraints or mates to create relationships between your models. Typically, this is done by removing degrees of freedom. In Fusion 360, we use joints and as-built joints to create these relationships. Let's take a look into the join command within Fusion 360. To find the join command, you go down here to Assemble and click on Joints. First joint we're going to do is going to be using the gear shaft. We'll click here on the center, and then next we will click here at our gear housing here at the center. Next we will go down here at the motion, and we will select what motion we would like. For this instance, we want a revolute. And click OK. Let's create another joint and connect the gear to the shaft. We'll go back to our joint command. Then I will select the center of the gear, and then go to the shaft and select the center. The motion, this one we're going to use rigid. And press OK. Now if I drag the gear, you'll see it stay in place, but it also rotates around the shaft. Now let's continue our assembly using as-built joints. The distinction between joints and as-built joints is that as-built joints are intended for components that are already in their correct location. Let's go to our as-built joint command to connect the blade holder and the guide block. It's asking me to select the components. So I will select the blade holder and the guide block. Next, it's asking us to select the type of motion. This will be a slider. Then we select the edge. As you can see, it created that relationship. Press OK. Lastly, let's define our connecting rod and see how our assembly is coming together. We'll go back to our join command, and for this origin mode, we will go to between two faces, select the bottom face, top face, and then just the middle. Our component 2, we'll go to our blade holder and select the center of the shaft. And then our motion is revolute, yes. And lastly, we will go back to our join command, select the bottom center, and then for the gear, we'll select the top. And then for our motion, we'll keep it at cylindrical to allow for some tolerances in the Z-axis. Select OK. With all of our components defined, we can use any components to drive the open degrees of freedom. And if you have a look at the timeline, this linkage was only created using 4 joints. Next, we will be looking at the joint limits and contact sets. Looking at the joint limits, using this vise as an example, you'll see whenever I drag the sliding jaw, it goes out of the boundaries that they're actually supposed to be. So one way we can achieve by keeping it in these boundaries is going to your Assemble tab and say Enable Contact Sets. You'll see down here at your browser a new tab has come up. Then you just right click and say New Contact Set. Then it's asking you to select the bodies or components. So in this case we will select these plates and select OK. So whenever Fusion picks up that these two are against each other, it'll stop. Okay, it stopped. But setting up too much contact sets does take up a lot of your computer's resources. Another way you can also achieve the same results but without it taking up too much of your computer's resources is by setting up limits within the joints. So I'm just gonna disable all the contacts here, so it works the same as before. So what we'll go is we'll go down to our joints tab, and at the slider joint, because this is the slider 9, we right click and say edit motion limits. So here you see you can't edit any of the limits yet, you have to tick on these boxes. So the minimum we're going to set it at -7, and then the maximum I'm going to put it at 30. You can also put in a rest limit, so let's make that 15. Select OK. So whenever I drag this, you can see it stops it where I've set that limits. And it also doesn't take all of your computer's resources like the other option. We have now come to the end of our webinar, where we have showed how to create a component, add joint, and setting joint limits. Thank you all for joining, and we hope to see you again soon. Next, we will go on to the Q&A section. We will answer any questions that you might have. If you have any questions, please feel free to leave them in the chat section.